There you go. Yes. Okay, so today it is 119. So what we want to do today is take a look at 4 different types of graphs. These are called the parent functions. They're called the parent functions because they're like the basic graph. There's nothing special about them. They are called the parent function. This is called the constant function. Now, constant function stays constant. It's like an English word, okay? So if it stays constant, it's always going to be 1. So if I look at this, it's always going to have a height of 1. That's my parent function, okay? This is linear, okay? It's going to be start at 0, and it has a slope of 1 over 1. Those are invisible numbers, right? But that's our linear function. This is our absolute value graph, and we looked at this last semester or in geometry, and the absolute value has a V because the negative part of this graph flips up and becomes positive because absolute value graphs have to be positive. So, and then finally the quadratic, like this is like 1 squared, 2 squared, 3 squared, or negative 1 squared, negative 2 squared, negative 3 squared. Again, we learned these in geometry, okay? Now domain and range. Domain is all your x values. Domain is x values. And so if we take a look at this first graph, here's my x-axis. It goes forever, right? So the domain, they say, is all real numbers because every possible number, see how it goes back and forth, every x values on this graph, okay? The range is all y values. Well, in this graph it only has one y value, and that's 1, right? So that's its range. The second graph, linear, okay, it's a straight line, but it goes through 0. How wide is this graph? Well, the x values is all real numbers, right? It's forever wide. And the y values, it goes forever up and ever down. Okay, look at this graph. Is it going up forever? It's going down forever. Those are the y values. Look at the x values going forever over and forever back. Okay. This graph, though, the absolute value graph is different. It is, the x values do go over forever, right? But the y values, there's nothing down here. I mean, this graph doesn't go down here, so there's no negative values. So these y values are from 0 up. So they say the range is y is greater than or equal to 0. Starts at 0 and goes up, okay? This graph is just like this, just different shape, okay? It is forever going over. Even if it goes up and up and up, it's always going over. This is going up and up and up, it's always going over, right? So all real numbers for the domain, and then the range, it starts here at 0 and goes up. It doesn't have any values here, okay? All right, so these are what we call the parent functions. Now what we want to do today is change them, okay? So let's take a look at the notes I gave you. So objective today is we're going to do translations, 1, 19, 21. Translations of parent functions. Okay? Translations of parent functions, okay? So I'm going to use 2 different colors because I want to put the parent function down and I want to put the regular graph down as well. So I'm going to use 2 different colors to do this, okay? So I'm going to do my parent function in blue, and then I'll do my changed graph in red, okay? All right. Y, now fx and y are the same thing. So if I looked at my journal, we already did this one. We did. Page 25. There it is, right? That one's been graphed, so we're just going to put that down. Y equals 1. Fx equals 1. So I'm going to graph this one. I'm going to go up to 1. I'm going to graph it. Okay, there it is. That's my parent function. It's like the basic function. And then I'm going to graph g of x. So g of x is a change, right? G of x is going to be, instead of at 1, we got to go down to negative 3. So here's my f of x, that's my parent function. And here's my g of x at negative 3. So what happened? So we want to describe it. So in words, we could say, well, it went down 1, 2, 3, 4, right, in words. Down 4. Good. Mathematically, what happened was we took f of x, we went down 4 to make g of x. We took f of x and we went down 1, 2, 3, 4 to make g of x. That's a better description. I don't mind the words, but eventually we're going to have to start using the formula, okay? Well, let's look at number 2, okay? Because if I keep doing a couple of these, you guys will get the hang of this, okay? So, number 2, first of all, f of x equals x. Well, I think that's in our journal. That was that one, right? So we know it's going to be that graph right there. It's our parent function, right? So we're just going to put that graph onto here. We know we're going to start at 0, up 1 over 1, up 1 over 1, up 1. Okay, so here's my parent function. Right? And it has numbers that we don't normally write. Plus 0, I start at 0, slope of 1 over 1. Okay, so there's my parent function. That's f of x. Now g of x is different. It has a y-intercept of -4, right? We saw that on our warm-up. So I'm going to go down 1, 2, 3, 4, right? It's my y-intercept. And then this has a slope of 2 over 1. It's got an invisible 1, but 2 over 1, right? I like a fraction there because slope is rise over run. So I like a fraction there because the fraction helps me. Slope has to be a fraction. So I'm going to start at -4, and then I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. So I'll start at -4. And I'll go up 2 over 1, up 2 over 1, and there's my line. So describe, okay, so in words, and words are okay for right now until we get used to the formulas. In words, what do? We went down 4, didn't we? We took the blue graph and we went down 1, 2, 3, 4, right? And we also made it twice as tall. As a formula, we took f of x, we went twice f of x, we went down 4 to make g of x. We went twice f of x, so we doubled the height, and we went down 4. That's what I like. I like that better. If you give me words in the beginning, I can take words, okay? But I like that better, okay? All right, guys, ready to flip the page? Am I going too fast? How am I doing on my pacing? Emma, how am I doing? Oh, good? All right. Emma doesn't mind if I pick on her. Right, Emma? Nah. Emma's used to it. Just shows I care, right, Emma? Yep. Okay, so absolute value of x. Oh, hold on. Now, we did that. It was in our journal, right? It's that graph right there. That's our parent function, so I'm going to put that down. So it's a v. It starts at 0 and goes up 1 over 1, up 1 over 1, up 1 over 1. Okay. And then it's the v on the other side goes up like this because those are the positive values. Okay, so that's my parent function. Now, we've got to make sure you know that. If it's on the inside, it is going to move horizontally, but the opposite. All right, you guys are finally in class. I don't know if anybody was in there when I did the dance. You there when we did the dance? Anybody in there when we did the dance? You guys remember the dance? You guys remember the dance? Nobody remembers the dance? Okay, ready? Here's the dance. Okay, so the dance. So here's my parentheses. My parentheses. Okay, now, which way am I moving? You're going to say I'm moving to the left, aren't you? But from my perspective, I'm moving to the right. It's the opposite, right? Okay, watch the dance. Okay, good dance. Okay, mention that parentheses, right? So, from your perspective, I'm moving to the right, but it's the opposite, on the left. Now, there's a reason why, which I'm going to get into later. There's a reason why it's always the opposite. So what I'm going to do is I'm going to take this graph and we're going to move it back 2 and then up 3. So to move it, let's just take the vertex. This is called the vertex. Vertex is that point right there. So let's just take the vertex, move it back 1, 2, and then up 1, 2, 3. How's that? So it's the opposite of the inside. Here is why. Here's why. If I put -2 in for x, -2, it's 0 it out, right? And that makes it at its lowest point. That is why. Okay, now, describe it. So here's my words. I already used my words. There it is. And I'm also going to describe it by putting in what this is, and that is we took f of x, and we went +2 and then +3 to give me g of x, okay? That's the mathematical description, okay? Real quickly, if I want to ask for domain and range of this function, okay? Now, domain, I want domain and range of that one, okay? Domain is x values. How wide is the red graph? How wide is it? How wide? I mean, come on, you guys, somebody show, how wide is this graph right here? How wide is it? It's forever wide, isn't it? Forever wide, right? So the domain's going to be all real numbers, because it means every single number is part of the domain. The range is different, though. I always like to say, reach for your range. Reach for your range. Well, it starts at a height of 3, right? This red graph starts at a height of 3, and then goes up. So we're going to say y is greater than or equal to 3. Okay, last one, and I'll be done. All right, fx equals x squared. Go to page 25. What does that look like? It's the parabola. Right, so it's going to look like this. Here's how I'm going to graph the parabola. Okay, listen carefully. I'm going to do this one in. Okay, listen carefully. 0 squared. 0 times 0 is 0, right? 1. Watch. 1. 1 squared. What's 1 times 1? 1. 1, 2. What's 2 times 2? 4, right? 1, 2, 3, 4. That's how I'm doing an x squared. 1, 2, 3. 3 squared. What's 3 times 3? 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's off the page. That's okay. Now, -1 squared. What's -1 times -1? +1. -2. -2 times -2 is a +4. 1, 2, 3, 4. -3 times -3? Well, that's easy. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so here's my parabola. Okay, we learned that last semester. Maybe you did. Hopefully you did. But that's a parabola. Right? And then what we want to do is we're going to change it. Okay? So let's take it up 4. So I like to move the vertex. Okay, we want to take it up 4. And then this negative here is going to make it upside down. So then we're going to make it reflect. So we're going to make it up, side down, or we're going to reflect over x-axis. So I'll let you guys go ahead and write that down, okay? So that negative right there makes it a -x squared. A -x squared is going to make it upside down, okay? So I'm just going to take this blue graph, my parent function, and make it go upside down. That's all. My blue graph, parent function, make it go upside down. So it's going to look like this. Right. How's that? Okay, so now, today on